Được không?
Ngày cuối là
Okay, so let's start, right? So, hi everyone, thank you once again for joining with us for this Ruby Tuesday event. Today is mark the 13th event. So I believe most of us are familiar with the schedule. Right? So as I said before, in case you don't have access to Wi-Fi, please scan the QR code. And please join our Slack community. To be honest, we have been considering joining, switching to Discord, but we haven't made the effort so far. Yeah, it's still on the to-do list. And please follow us on Meetup for the upcoming events. Just a head up that in January we still have the Ruby Tuesday event 14, but in February potentially we will cancel the event because during that time is a holiday month, Tet, right? So it's likely a lot of people will be on holiday or traveling, so it doesn't make much sense to hold the event that month. So maybe we can skip that event in February. We also have a Facebook group for our Facebook page for the updates. And the important thing that please share your feedback regarding how we can improve the event. So I mean your feedback would be very valuable for us to make the event more helpful and engaging for all the audience. Regarding today's schedule, so we will have two sharing, one for large language model and semantic search from Giang. Then as usual we will have a short break so we can hang out, taking some food, and we can discuss any other topic. Then we will move on to the second topic of how Ruby become faster over the years and what JYIT has to offer. If we still have time, we want to keep the event within schedule. I mean, not too long. So we try to aim to finish it before 8:30. So hopefully you can still have time for the Ruby quiz session. And after that, if anyone still have something to discuss, we can have a lightning talk and Q&A. That's the schedule for today. So now I will hand over to Giang so he can share his talk.
Anh đưa thế này nhưng mà không có cổng HDMI rồi. Type-C có cái công truyền ấy. Em sao nhìn là màn hình? Đây là màn hình không? Được chứ? Đó. this wait a second. This hả? Này định tính làm thêm mấy issue đừng con đen nó hàng anh là hàng nó uống luôn
Thank you all for coming here today. My name is Giang, and today I'm going to talk about AI and semantic search. Before I begin this session, so I'm going to ask you a question. Have anyone here never used JYIT before?
Yes, I do. I think most of everybody in the room should be familiar with that.
Oh, so well, that guy here used JYIT before. So this topic I'm gonna talk about the technology behind JYIT. The first, this is the table of contents. This session is first I'm going to talk about the LLM and definition of LLM. Second, I'll talk about the OpenAI. First, I'll compare one of the use cases to use the LLM model to create the full text and semantic search. I compare them. Next, I'm will give you a demo for semantic search and kind of I will ask the section for give me some question and answer. So first, LLM, the definition LLM is large language model. It's one of the algorithm of AI. It's a UK for summarize some native language text to the algorithm, to the model, and to image what is LLM. So I give you an example, like if I tell you what tone is dot. So I predict the next word after tone is. Depend on the context of the sentence. Like tone in the cartoon context is tone me a cat, but tone in a film context is tone me an actor. The LLM is a model help you predict the next word appear in the sentence. So I'm going to talk about some definition in the LLM. It's a parameter inference tokenized model. So about parameter. So the parameter is number of weights of the model to neural network. This means the model has more parameters. It means it's more powerful, more accuracy. It's based on the data. It's one of the pictures about the size, language model size, until the mass of details. So the next, let's talk about tokenized. Tokenized. Its tendency have many words, so we have to be tokenized any word to save to the database with a sequence. It's not repeat and save it in the units in the data. It's a symbol for the tokenized, like OpenAI last is a token. Using the token, the model is the token. Although there's over 300 characters, but it's only have more than 15 tokens right here.
I have a question. So is it fair to say that token is the same as word? Like, see, like this is represent different word, right?
Like width is not a token.
Oh.
It's like it could lead the sensei with some keyword. They read some keyword like they don't take it. They don't take off. Take it. This word to be a token. This word is to a token and token is connect word.
Okay. The model learns.
So which one are tokens in that picture? Which one are tokens? I mean the colors that you use. You have 4 different colors, 5 different colors.
This sample from ChatGPT, the tokens is the relationship open model.
So the purple ones are tokens and the other ones are not tokens, or we have different colors over there. Are the colors have any matching to tokens and not tokens, or they're just split over there randomly?
So this focus suggests which learn to is not calculated as a token.
So the green ones are not tokens.
He means on the pictures that there are different words like marked with different colors, right? Red, orange, and yellow and green. So which color are considered tokens and which one are not?
Actually, the first sentence, the first character didn't appear. The token is already appear here. It's not calculated as a token again.
Okay.
It's square sequence. Yeah. Sequence.
So the colors have nothing to do with the tokens. They just split the words. The colors are splitting the words, and they have nothing to do with the tokens.
It is sample for the way they define the token depend on the algorithm in some model platform. It's the way to OpenAI calculate the token. Maybe in another token they can consider to take another algorithm to find token. With OpenAI, they take open with the first time they appear in the token, and that time this sequence is not it appears again, it's not the token. So one of the mechanism in the LLM is retrieval augmented generation. Is how to the LLM model connect with your old data. Your data in some field of the technology or some field of your job, your data. Like that. If you have the LLM trained in the amount of data of big data is actually not related to your business. So you have to train data to understand what the data in your business is defense. This is the defense. So maybe it's LLM has a lot of definition, but actually I'm got here. And in the slide, I not have include some of the UK this slash. So we move to the my own my keyword. So the next is talk about the use case. UK for the LLM is mainly at least for some UK years, like the sentiment analysis customer service or build your chatbot or build your online search for your own data. Yeah. And based on the LLM, so we define some advantage and limitation for this technology. So the first, with this LLM, you can have a great with the productivity. So next, we take consider about the accuracy because with the data set we train for the data model of LLM. It's not enough bigger, so the data is not really correct for your research. Yeah. The first is the compatibility with your data, and next is risk about leak your sensitive data when you use AI. So I already talked about the LLM, so I move to next session is the OpenAI. So OpenAI is an AI research company, it's a corporation to build some product based on AI. So the biggest product from two biggest products of OpenAI is ChatGPT and JYIT. And ChatGPT for large model and JYIT for build for generate some pictures. Next, I will talk about some configuration for the ChatGPT in OpenAI. About temperature. I have a playground here with some of configuration here. Like when you configure the temperature, it means you can generate the data with a more diversity reserve. It's not, maybe it's not correct, but it have a more creative way with the data. And maximum length is about the limits of the output reserve. And top P and frequency. Frequency is the don't repeat the whole data reserve. And here's in the API endpoint for the OpenAI test and embedding. And when you use the OpenAI, you have to consider bring about the cost policy, because the cost of OpenAI is a corporation, you know. It have a cost for everything you do with the API, the OpenAI. The next we're talking about, we're considering about the policy, because when you use the ChatGPT, it means you provide the data, your own data for OpenAI. So maybe your data can be leaked. So so we consider a content policy. So which way we can replace OpenAI with your own LLM model? So we can define some. Nowadays we have a lot more.
I'm sorry, could you please answer the full screen mode so it's easier?
So it's over here is some ChatGPT like, but it's local model. You can run this locally in your machine. What technology behind this this model? Because ChatGPT is a huge model. It's a billion, 10 billion parameter. It's a database really huge. You can run this model in the locally. So we can, but actually in some model over here we can run locally. The technology behind is the quantization model. It means the model and the parameter the technology set with the data type. The first is the data type. They minimum the data type like move to the one string, like the text to string. It's minimum data. And the next is the vector. You know, the one of the parameter I told you before, saved in the database. In the data, with the many vector, with the many data, then they have to save in the database with many dimensions in the database, like a relation in the database. So with some model here, they minimal the relation of the data by reduce the dimension in the database. So next technology, the technology behind it, you know, the ChatGPT is the technology based on the Python. It runs in Python and this model just be write in C++ and run, and you can store it in the RAM instead of the VRAM with like OpenAI. And next, you can run locally, so you can run this without policy leak data, and it's open source. Yeah.
I'm sorry, can I have a question? Okay, this question might sound a bit like naive, but I wonder, like, in terms of advantage, like, does ChatGPT model have any like inherent advantage over these open source model? Do they have any, I say, secret technique that they have? I believe that ChatGPT is closed source, right?
Yes.
So,
but actually the data they train it's huge data because the algorithm is the same, but the data input is bigger.
So is it fair to say that the advantage that ChatGPT have now is because they are start earlier, they have more data, so give these guys enough time, they're gonna catch up?
Actually, the ChatGPT is more powerful because its data, its model size is bigger. But actually, with the next gen technologies, maybe can reduce the data with the latter percent, maybe within 10%.
I see. Thank you.
With the qualified, within 10% of the qualified output. Yeah. But maybe with some business case it's acceptable. Yeah. So next I'm going to talk about the comparison of the full text search and semantic search, because semantic search is one of the use case when you use the AI to searching in your data. Like if you have a amount of data related to some field, and you can like you did write about an animal, and in the topic don't have any word about correct word in animal, but you can search with the animal word. Understand?
I see.
You are search animal, but in the topic don't have any words like animal.
Yeah.
The semantics The full text search, this means you have to in your topic have to include the word animal.
Yes,
Yeah.
it has to be a match or a partial match.
Yes, and a partial match. The understanding of query. The first to consider is the understanding of query. The next is matching technique. It's different because it's a tool of the main feature to considering about the semantic about the flexibility and precision and application of usage. Maybe it depends on the business. So next, this is the comparison about the protected and semantic search. So I'm going to deep dive about semantic search. So how semantic search works. The first, you have to create chunk from the when you have a sentence or topic with about the word, right? About that, then you have to create chunk based on the sentence or topic, because some of the API or some of the LM have limit for tokenize. So you have to change the sentence or topic to manage. And after creation, like with the management, they call the API for empathy. The sentence or the word with base to be a vector. Let's return let's see the velocity of that. The assets in the database dimension here of that, and next we set the empathy vector to the local database. Call API. The first is call API, and next we say the empathy. When you call API, they return the asset of database. So we set empathy vector to the database. So here's the some of the database support to set the vector database. We set the empathy vector. Next. When you already embedding all your data, and we want to search, we're looking for some topic, some search about some work in so we input work, so we have to calculate the input. Wow. So like you want to search about a dog, you have to call an API and embedding that dog with that work like dog to be embed and to be a vector. So next, with the database we already saved, and the work we calculate before, we find a label. It may be not correct, but actually it's related with related to the topic I'm looking for. The final step is return the result. So I move to the demo right now. It's maybe easy to. So here's I create a demo for semantic search here. So I have a schema here. I have a main model article.
I think you should like increase the font size a bit so the guy in the back can see it. Yeah. Yep. Okay. I guess it's too big now.
Yes, yes. It's like have a model article. There's an article with title and body. Don't care about it.
Pattern.
So if I and the view. Server.
Mình nhờ viết cái ngang này.
Have the more here. Here's article. Here is the search box, and here's the reserve search. Yeah, we have a sample and have a deployment. We have the design. This, you know, the body. I'm sorry, based on the body of the article. What's actually the body is not include the deployment. You know. It's some of the powerful feature for the research. And how I create a feature. The first step I create a model. It's named Chun. Chun is just the first. Let's see. I'm doing a demo about the embedding step for the database, for the data, like the article first body. That's the amount of text right here. You can see here. Yeah. And with OpenAI, we call embedding this to the vector. Yes. You know, this is dimension vector after embedding. This means the body here, or it's set in the data of the OpenAI in this vector, and after we embedding, we set this to the article embedding vector. Here, I already did set it. Yeah, corrections at embedding. Yeah, we the article have many chunks because the chunks is the one when you have a amount of article, it have a lot of token here because the one code of API has limit token. It has limit, so we have to separate the input for when code API. So I define the chunk model to separate it, and it belongs to the article. So here, article, and it's separated by the dot, because its synthesis separate with error by the dot, right? That and they move on adoptions. Yes, I have example for chunks. You know, did the synthesis, and I'm create 2 chunks based on the synthesis. The chunk size, either the length of the workplace and the chunk overlap is mean. Maybe you can see this one here. This one. This bit here. Separator is in maybe you can dot or brick line. And after we create chunks, so we call average for each chunk, like a blank chunk here. We call average and set to the database. Yeah. Database is chunk. I'm calling it the vector average. Yeah. Yeah. Article update embedding and chunks create content based on the article chunks, article first chunks. And then the separate one chunk only, and after creations we are embedding the chunk with OpenAI, and chunk create content based on it and embedding it the result after call API. It's a vector. So we got a vector. So and so we find the label of the vector. It's the result for the semantic search. Like here is the demo for the related vector. The first vector is just first element. The second vector is I'm looking for the word AI technology. It's not safe to database, but it call API to generate the vector here, and make the third vector another word. So we have a first vector is the chunk we already set to the database, right? And the second to third vector is the input you input and already embedded by API, call API to call the vector in the OpenAI. So this is the logic how I can check the related to the result in the database. So the second vector may be called inner product with the vector. The first vector is saved in the database. The related is 1.7. The third vector is 1.8, and the fourth vector here. Yes, right.
I'm sorry, can I have a question? Okay, so uh, the size of the vector, like the amount of dimensions that it have, does it like the more dimension I get, the more precision?
Yes, yes. The
Yeah.
more dimension,
Okay.
the more dimension.
So
It
how many
depends.
like dimension you have in?
Actually, it depends on the API you use.
Ah,
And with the embedded model of OpenAI is yes. Yes, dimension is
okay. Oh,
Yeah, that-
so do you have a reference number of how many ChatGPT or OpenAI have?
the dimension, right?
Yeah. Do you have any? I mean, a reference number so that I can imagine like how big they are, like million or something.
There is the model size.
Oh,
It
yeah.
depends on the model size. It's one model size.
Okay.
Yes. So I demo for you the related of the work. You input with the data, you save it in the database, right? Yeah. Yes.
Yeah.
You know, you can see here with the 1.9, it is
Yeah.
it is more related to the
Yeah. So you calculating the dot product of two vector. So
Yes.
if they are like the same, they're going to be one,
Yes.
right?
Yes.
And as close as one is meaning they have like closely related or like in the same space
Yes,
in
the
the
same space.
area.
Yes.
Okay. Got it.
Giang, I'm sorry.
Got it.
How long do we still have for a remaining session? I think we need
Yes,
to
it's done right. It's done now because
I'm just worried that we need to keep everything in now.
Yeah,
That's
yeah,
why we
yeah.
need to speed up.
So then, so I'm finished the demo right now. Actually, so we can see here the demo is what upload is. It not appear in the body of the article. It's about
I
the
see.
action itself. Yeah. So thanks for listening to my presentation.
Yeah, anyone have questions?
I
do.
Yeah.
I'm just curious, what is the database that you use for PostgreSQL?
Actually, Postgres have a plugin support for set the vector database.
Vector.
Yes, busy vector.
So, is it more efficient if we use a vector database?
The
Vector database.
vector database.
Is it more like efficient than using a Postgres? Because I
Postgres,
know that
yes. Background.
yeah.
Ready search. Yeah. There's some database you can use to save the handling vector.
So it's more efficient. Right?
The division depends on your configuration because maybe some database supports 3-dimensional, 5-dimensional, many dimension.
I mean, I'm sorry. He means that is it more efficient?
Efficient.
Yeah, is it more
Is it
efficient?
better?
Yeah.
Like
Is it better?
better result if you use a vector database?
I have to calculate it right now because, but actually the vector lookup is not really yeah.
Okay.
So I think this is depend on the dimension you set only. Yeah.
So basically, we just save the embedding in the local database, and we still need to call the API to OpenAI to do the search for
Yeah,
it.
yeah. We set the embedding vector. We already code on OpenAI to got the embedding vector and set to the locally. And if you looking for some, if you search and you call the word you search in the OpenAI and you got the embedding vector for the search inputs and you compare with the local vector to looking for the code, looking for the mirroring the result with the word. Yeah.
Okay, right.
Yes.
Thank you.
Thank you.
Anh nói semantic search của bạn là search theo cái ngữ cảnh không?
Đúng rồi, ngữ cảnh là Google.
Nhưng mà cái Giang search là tại vì đang cái Giang search bao nhiêu môn.
Thật ra thì ví dụ cái từ này nó không có bên dưới này.
Đây có exploration đúng không?
Giờ anh tìm từ khác.
Từ thì nó đâu có ngữ cảnh.
Bây giờ anh tìm từ khác.
Thường câu có ngữ cảnh.
Ví dụ tìm từ này thử nha. Đây này. Ví dụ cái tìm đồng nghĩa. Lấy từ này luôn đi. Đây. Đó. Nó không có trong cái từ nha. Không nốt drum. Không ta. Này. Đây, bỏ có. Tìm thử từ đây, Bonirium. Từ này không có này. Nó vẫn ra cái bài này. Nó vẫn ra bài này. Anh bỏ Semantic đúng không? Tìm từ này.
Thằng em nó lột mồ rồi. Biết chuyện mình.
Đây, tìm từ này nhưng mà nó ở đây. You know?
Organic.
This was not appear in the body, but actually you can do.
Actually, there are some similar words.
Cái kiểu cái engine của Analytics search nó cũng so sánh theo vector thì cơ bản nó cũng sẽ, nếu mà so sánh theo từng từ thì cũng không, tức là cái kết quả của nó cũng sẽ không chứa cái từ đấy, thì cái công tác này nó cái điểm nó không có chỗ đâu.
Đúng rồi, như Google. That's all. Do you have any question?
Yes. Okay. Which is the role of Redis in the application? How to verify
Ready?
the result more faster?
Yeah, actually I use the render based on the hot wire. Hot wire. The technology for front end.
Okay.
So Hotwire need Redis. Okay.
Yeah, actually hot wire need socket. Socket
Yeah.
need Redis.
What the fuck?
Okay.
You socket and you pull a whole Redis? What the hell? I mean, what the hell is wrong with Ruby?
Thanks for listening today.
So before we move on to the